anything. We know when we factor a trinomial, we always get. Oh, I want you black. We always get two binomials. Like that. We also always know that the first terms of your binomials should multiply to be the first term of your trinomial. So in our case, 5x squared should come from right here, 5x, and right here, 5x. We know only one of them should have been a 5. Making them both 5 is wrong. That's where the diamond incorrect comes in. Right? The sides of your diamond, which is the +5 and the +2, still goes in as the sides of your binomials. If this was a regular diamond method question, that would be the answer. However, this is not a regular diamond method question because A equaled a number that wasn't 1. I need to correct my mistake of having too many 5s here. One of them should divide by 5, one of them won't divide by 5. If you look, the first one divides by 5. When you divide by 5, you get x plus 1. Remember that those things don't cancel out, right? Some people go like, oh, 5 and 5 cancel out, and then they just put x. 5 by 5 equals 1, so you have to put plus 1 there. Over here, we have 5x plus 2 still. My two binomials after I factored was x plus 1 times 5x plus 2, or vice versa. You could reverse those two. Fantastic. Those are examples. Actually, I don't know if I want to do all of these. How about you try it? You try A. Give A a shot, and then I'll go through it with you. Just see if you can just set up the diamond. I'll do it chunk by chunk, so you can go along. Alright, so it's all up there now. Hopefully, if you are getting stuck, you're able to see like where you're stuck at and why like you're getting stuck there, right? So if it's like, oh, I'm forgetting how to make the diamond, or I'm forgetting how to divide by 6, or you're figuring something out along the way about yourself and how you're learning. And hopefully you can answer those questions to yourself of what am I doing wrong? Alright, B should work out nicely. C might actually have a bit of a curveball to it. So if you look at B, we build our diamond. The top of the diamond would be 816, negative 24. Bottom of the diamond would be negative 2. Things that multiply to B, negative 24, and add to be negative 2 would be 6 and 4. So it would be negative 6, positive 4. Again, if you're stuck on the diamond, focus on the multiplication, right? Because it's a finite number of things. Awesome. We then know that when I factor a trinomial, I get 2 binomials. We're going to have to go too far into the next question. The first terms create the first term of your trinomial, so it's going to be 3n and 3n. We know that's wrong. Only one of them should be 3, right? The sides of the diamond, negative 6 plus 4, allow us to correct our mistake of having too many 3s. One of these things should divide nicely by 3. The first one does. When you do that, you end up with your final answer of n minus 2, 3n plus 4. That would be your solution. Okay, C. I'm pretty sure C has a little bit of a trick to it. So if we look at that one, we see it's a trinomial. We do our diamond method. When we draw our diamond, it's an awful diamond, but I just realized I was going off the board. The top of the diamond would be 12, the bottom would be -8. Things that multiply to be 12 and add to be -8 would be -2 and -6. Right? A negative times a negative becomes a positive, but a negative plus a negative is still a negative. So -2 and -6. All right, the diamond is made. We go back to our trinomial. We know trinomials factor to become two binomials. We know the first term comes from the first terms. So this 12x squared means that these should be 12x and 12x. We also know the sides of our diamond go in here. -6. -2. Here's our problem. I said this one was going to have a little bit of a trick to it. We need to correct our mistake of having one too many 12s there. Right? 12 and 12 would be 144x squared. We wanted 12x squared. We know that's a mistake. Right? It's the same one we've been making over and over and over again. We say to fix that mistake, we divide by 12. Neither one of these things divides by 12. Hence our problem, right? And it's like, now what do we do? So instead of dividing by 12 in one entire piece, you're going to break it up into two pieces. So what are two numbers that multiply to be 12 that I could divide one out of this binomial and one out of this binomial? All right, things that multiply to be 12, 6 and 2. Does one of these divide by 6? This first one could divide by 6. Does one of them divide by 2? Yeah. This one divides by 2. So you're still dividing by 12, you're just doing it in chunks. 6, 2. So anytime you can't take it out in one big piece, like we had been before, you break it up into two things. Your final answer then would become 12 divided by 6 is 2x. 6 divided by 6 is -4. Second binomial, 12 divided by 2 is 6x. -2 divided by 2 is -1. That would be my factored solution. And if you multiply 2x and 6x, you would get 12x squared. Right? The first terms are still creating the first term. It's just doing it in parts this time. Awesome. We got a couple tricky ones here. So class example 5, we just have two special cases here. The first thing is, when I go to factor a trinomial, I want it to be in the form ax squared plus bx plus c. That means I want it to be a descending form, right? We've talked about that. So highest exponent first, then lower, then lower. So this guy right here is not in descending form. So I would rewrite it. So I would rewrite this question to be -2y squared minus 7y plus 15. I'm just reordering it to be in the proper trinomial form I'm used to. Awesome. That question can't be factored right now because there's an issue we haven't talked about. The issue we haven't talked about is that your A value must be positive. It always has been positive for us. It's always just been set up that way. So we haven't really talked about it much. I think I might have mentioned it in passing in like a 1 hour thing. I'd talk forever and you guys probably didn't even hear me, right? though, they've given us a negative a value, so we have to deal with this situation. To make a positive, you're going to change all the symbols by factoring out a negative 1. It's like doing a GCF. Okay, so what we're going to do is we're going to go up here, we're going to change all the symbols. So this will become a plus 2y plus 7 negative 15. And we do that by putting a negative outside and then putting it in brackets. Like that. So I changed all the symbols. I factored out a negative 1. That's what I did. I took a GCF of negative 1. Now you have a trinomial that can be factored using the diamond method. If you had factored with a negative a value, you probably found numbers that worked, right? Like it probably worked out all the way. But if you multiplied it back together, there's probably a mistake somewhere in there. The negatives just make things hard. It just throws things off. And sometimes it might work out, but sometimes it won't work out. If you make a positive, it'll always work out. Okay, that's why we do it. That's why we switch that negative to the outside of the brackets and put the trinomial on the inside. Awesome. We'll run through that factory. So we have a diamond method question. Top of the diamond is negative 30. Bottom of the diamond is 7. Sides of the diamonds are 10 and negative 3. The negative 1 is still up front. Then my trinomial would become 2y plus 10, 2y minus 3. The 2y's give me the 2y squared out front, the 10 and the 3 came from the sides of the diamond. I know there's a mistake here. One of these has too many 2's, so we have to divide one of them by 2. When we divide that one by 2, we get our final answer of negative, and then y plus 5, 2y minus 3. Awesome. Last one. We look at that thing. The question says factor. To factor that, I use my factoring decision tree that we've been building over here. The first type of factoring we try is GCF. You can GCF this one. What can come out of that? A 5, right? A 5 can divide into every single number. You need to GCF first. Otherwise, you're going to end up with the wrong answer every time. So when I take out a 5, now I'm left with 3k squared plus 1k minus 2. And you factor just this trinomial. Right? The 5 out front doesn't do anything to my factoring. It just stays out front. But the trinomial, I factor using diamond method. I'll give you a second to try to use diamond method. It will be diamond incorrect, so give it a shot. Awesome, so I'm just going to finish this off. So the diamond is on the side, right? We go back to our question. The 5 that I took out as a GCF is still out front. The trinomial will turn into 2 binomials. You know the first term, the 3k, right here, has to become the first terms of my binomials. Like that. The sides of your binomials comes from the sides of your diamonds, plus 3 minus 2. One of those binomials has a 3 and it shouldn't have a 3, so we have to correct that by dividing one of them by 3. The first term divides by 3. That means my final answer would be 5, right? That's the GCF. K plus 1, 3k minus 2. Like that. Any questions about those guys? Diamond and correct's probably as hard as it gets, I think. Especially when you have to do a GCF to start it off. There's a lot of steps, right? And with factoring, like there's a lot of steps. Like there's a lot of different ways to do things, and you just need to be able to know all of them. Because when it comes to a test, it's not going to say factor using the diamond method. Right? It's going to say factor. And it could be any of those different scenarios we have. And you need to be able to know which method to use. Right? The methods are easy when you know which one to do. So that's why we built that tree. It's helping us decide what to do. Awesome. There's tons of practice questions below.